Hello, and welcome to EE 3401 Engineering Electronics. This is just a short overview of the course and what you can expect when taking this course. The topics we cover are fundamental semiconductor devices such as diodes, bipolar junction transistors, metal oxide semiconductor field effect transistors, and also operational amplifiers. Operational amplifiers are created from semiconductor devices, resistors, and capacitors. They are one integrated circuit, and they can be used in a lot of analog applications by adding external components, whether it be resistors, capacitors, or inductors. The suggested text is by Cedra Smith, Microelectronic Circuits, 7th edition. There is also a companion website for the textbook if you are interested. The URL is presented here. This is a hybrid class, so that means everything is on D2L except the one in-person meeting per week. We will either do a lab exercise or take a test during those weeks, which means we will meet every week during the semester, including the first week. You have to attend lab during your assigned lab time each week. You can't switch sections, so you need to stay in whatever lab you're in and attend during the time that you signed up for. The type of assessments in this class, there are participation assignments. They're every week or 2 weeks, depending on where we are in the semester. You can work with other students, you can go to the peer mentoring center and get help, and you can check your answers with me before submitting. You can email me, you can ask me during our lab time, whatever you want to do. You can come to office hours, or you can email me, that's fine. Answers have to be entered on D2L to receive credit, and one of the assignments is dropped. Homework assignments are a little bit different. There's only 5, but they're a little more complicated than participation problems, and they are generally more similar to test questions. In fact, sometimes they're harder than test questions. They are due by 11:59 p.m., the Sunday before each test, and that will be outlined also in your coursework as you go along. You'll be able to see when the homework assignments are due. Each assignment can be attempted twice. The problems are the same the second time you attempt it, but the numbers may be different, so just be aware of that. If there's a simulation called for, you only need to submit one. You don't need to submit more than one. A lot of times students will open the homework assignment and look at the problems and even take screenshots to know what their problems are, and then work on the problems. And again, you can check with me to see if your answers are correct if you want to, and then finally submit it when you're ready to submit. There are 5 tests during this course. Each one covers 2 to 3 weeks of class. They're basically divided up by topic, so we have one for circuit analysis, one for op amps, one for diodes, one for BJTs, one for MOSFETs. So you can bring an 8.5 by 11 formula sheet on one side. Tests are given during lab time, and the weeks we have tests, we generally don't have lab exercises. If you're taking this course in the summer, that may be different, but in general, during the regular semesters, fall and spring, tests are given, and lab exercises are given on weeks that we don't have tests. The test dates are in the laboratory schedule online, and the final exam can replace your lowest grade. The final exam follows KSU final exam schedule, and when I know the final exam time, I will put that into the laboratory schedule, so it may already be there. It covers all the course material. You can bring formula sheets from all 5 tests, and you can exempt the final if your test average is 90 or above. Not your overall grade, but just your test average. The first thing we cover in this course is circuit analysis, and the reason we do is because oftentimes students have a harder time with circuit analysis than they do with the actual electronic devices. So sometimes it's been a while since you've had circuits, so I try to go through and review some of the more important things that you will need. So Thevenin's theorem, as you can see, is one that we use quite frequently in this class. Norton's theorem isn't used quite as much, but it's good to know what it is. Nodal analysis, very frequently used and is also used by circuit simulators in general. Mesh analysis is useful. Sometimes it's easier to use, and oftentimes when we're analyzing transistor circuits, this is a useful technique also, but circuit simulators don't use this. And the last thing we use in here is superposition, which you may or may not remember from circuit analysis, but we'll go over it again when we get to it. But basically, we find the effect of each independent source in the circuit and then sum those effects and add them together. It's really useful for op-amp circuit analysis, and as you'll see, it really saves time. It actually makes the analysis much easier using this. So that's the general introduction, and you can carry on with the next video in the lesson.